Hey guys, let's solve the binary tree preorder traversal problem. So they are giving us the root of binary tree. What we need to do is return all visited node in preorder traversal. Well, first we need to understand what is traversal means on binary tree. Well, that means we are visiting all nodes of the tree in a structured format. There are three types of traversal in tree or binary tree. The first one is in order traversal, where we visit leaf, root, and right. And the second one is preorder traversal, where we visit from root, leaf, and right. Then the last one is post-order traversal, where we visit from leaf, right, and root. Let's take a look at the example 1. Let's say the given input is like this. So we're gonna visit from root, which is 1. Then we visit the left one, the left side, right? The left side is null. So we're gonna visit the right side, which is 2. Then we visit the left, which is 3, right? So the output will be 1, 2, 3. And let's take a look at the example 2. Let's say the given input is like this. So we're gonna visit on from the root, left, and right, right? So it will be 1, 2, 4, 5, 6, 7, 3, 8, 9. What if the given root is empty list? Well, we will just simply return empty list as well. Let's take a look at the last example, which is example 5. They are giving us the root of 1, 2, 3, 4, 5, 6. The expected output will be 1, 2, 4, 5, 6, and 3. Like I said before, the goal is to return visited node value in preorder traversal. Main thing that we need to understand is that preorder traversal means you are visiting the nodes from root, leaf, and right. To solve this problem, DFS is more suitable to solve it. Why? Because traversal means we need to go deep as possible before move to the next node, right? We can solve it using DFS with iteration style, or option 2 is DFS with recursion style. Well, because DFS are using stack, right? So we need to read stack to store the visited node. But before that, if the root is empty, we just simply return empty list. Then the third one is that while the stack is not empty or current node is not null, we also need the current node to get the node or as pointer. Then this will be return the result. Inside of the while loop, we're gonna need to get the current node from stack and push it to result. Then stack is last in first out, so we visit the right node first. After that, we visit the left sub tree. Well, let's say the given input is like this, right? I'm gonna copy this and this. First, the stack will start from 1. While stack is not empty, and so the result we use or current node not null, which is true, so we're gonna use all because stack is last in first out. So the result will push 1. Now the result is 1 and stack is empty list. Is not 1 have right node? Yes, we gonna visit the right node first because stack is last in first out. So we move the pointer, right? Current node is not 1 dot right, then stack dot push current node, which is stack push the tree. So we visit the left node. Now the current node is node 1.div, which is stack.push current node. Now the current node is not 2, right? So we push them. It will be 3 and 2. Okay, then we're gonna need to push them to the result again. One stack is not empty, or current node is not null, which is true. So we're gonna get the current node from the stack.pop. The stack now is 3, then result.push 2. Now the result is 1 and 2. Is not 2 have any left node or right node? Yes, that's why we visit the right node. Now we need to push stack.push. The right node of node 2 is 5, so stack.push 5. Now the stack is 3 and 5. Then we visit the left node, which is stack.push 4. Now the stack is 3, 5 and 4. Then we're gonna put them into the result again, right? One stack is not empty, or current node is not null, which is true. So we're gonna get the current node from the stack. Now the stack is last in first out, only leave the 3 and 5. Then the result will push 4. Now the result is 1, 2 and 4. Is 4 have any left or right node? No, right? So we just continue. Current node is at the top. Stack now is only 3. Result.push 3. It should be result.push 5. Now the result is 1, 2, 4, 5. And is 5 has any right node? Yes, which is 6, right? So it will be stack.push 6. This one is visit the right node of node 5. Stack.push 6. Now the stack is 3 and 6. Then is 5 have any left node? No. Sorry. It should be this one is left node. 3, 6. Okay, then right node is not, right? Okay, then we just continue. It will be just copy this. Else that is not empty, and current node is not null. Okay, then we are popping them. 3, 6. Now we are popping them. Then it will be pushing 6. The result will be 1, 2, 4, 1, 2, 4, 5, 6. And because 6 doesn't have any left node or right node, we continue again. We're gonna popping them. Now the stack is empty. We push 3. The result will be 1, 2, 4, 5, 6 and 3. And we just simply exit the while loop, return the result, which is 1, 2, 4, 5, 6 and 3. Let's turn them into code. Preorder Traversal root. If the root is null, we just return empty list, right? That result is like this. Let stack is empty, then stack.push the root, because preorder traversal is root left right. Okay, then sorry, we also need the current node. That current node is root. Well, current node is not null, or stack dot length is bigger than 0. structure the result and remove from stack. So it will be stack.pop because stack is default. Then we push them to the result. Visit the right subtree and visit the left subtree because that is default. So this will be if current not the right. If current not the right, stack dot push current not right. Then if current not dot leave is not now, stack dot push current not dot leave. Then the last one is we return the result. I think we can just simply using this stack or root leave right, so we can just simply push it right away. Then we don't need this, we're gonna use this. Okay, let's do the time and space complexity analysis. This one will be O and space because we need extra space to store the visitor node. Then this one, because we are visiting all node at least once, right, it will be O in time because we visit all nodes at least once. Okay, I think like that's all. So for this, it will be O in time and O in space. Okay, let's move to option 2, which is recursion start. Div as with recursion start. Okay, first it will be the same if the root is null, return empty list. Then create new traverse function. We call the traverse from root, and the second one is that with result to store the output. Then the last one is we simply return the result. Inside of the traverse function, it will be if the node is null, you just simply return. Then the second one is push the node to the result for validate or process the root. Then visit the left subtree. Then the last one is visit the right subtree. Let's say the given input is like this. So at first we're gonna call the traverse one, right? Inside of the traverse one, it will be called traverse 2 and call traverse 3. Meanwhile for this, it will push the 1 first. Now the result is having 1. Then inside of the tree, the result will push 2. Now the result is 1 and 2. Then we visit the left node, right? It will be traverse 4 and traverse 5. For this, 1, 2, 4, 5, 6, 3. 1, 2, 4, 5, 6, 3. That is preorder traversal, right? So it will be result push 4. Now the result is 1, 2, 4. Then it will call traverse now and traverse now. This one is simply return, and this one is also simply return. Meanwhile for this, the 5 one, it will be push the 5, Now the result is 1, 2, 4, 5, and we're gonna call the traverse 6 and traverse now. This one is return. Then this will be push 6. Now the result is 1, 2, 4, 5, 6, and that's all. Because 6 doesn't have any child node, it will be called null, and we just simply return. Then we backtracking, right? Because now all of this is already processed, we're gonna push on here, result the push 3. The result now is 1, 2, 4, 5, 6, and 3. Okay, I think like this all. Then we just return the result, which is 1, 2, 4, 5, 6, and 3. Let's turn them into the code. If the root is not null, if the root is empty, we need to create a new result. We just simply return the result. Then we also need the function traverse not preorder traversal means root with right. If the node is null, we just simply return. Then we're gonna push them first to validate or process the root. Visit the left node, then we need to visit the right node. Traverse not.leaf. Then the last one is right. Okay, I think like this all. Then we need to start from the root, right? We just simply return the result. Let's do the time and space complexity analysis. This will be on time and on space, because recursion using stack. I think like that's all. Let's see. Option 1 is if s with iteration style, right? And first, let result is empty list. If the root is null, we just simply return the result. Then the if s are using stack, so it will be let stack is empty. Preorder traversal. Main thing is that preorder traversal, we are visiting from root left right. Okay, then you can just simply push the root first to the stack right, while the stack.length is not empty, or current node is not null, so root left right. I think we don't need to check it on here first, because the stack we will start from the root, right? So we can just simply move the current node at here. Current node is stack.pop. Then result.push current node.file. Visit the right node first, then visit the leaf node because stack is default. If current node dot right, stack dot push current node dot right. Then we just simply return the result. Okay, it's working. This one will be on space, and this is on time because we visited all nodes at least once. Let's do the submit. Okay, it's working. Let's see the option 2 with recursion style. If the root is null, we return result. We're gonna call it from the root, right? Then we need to return the result. Const traverse node. If the node is null, we just simply return. Process the root or validate. It will be result that push the node. We only need the value, right? So result that push the node file. Visit the left node, then visit the right node. This will be traverse node dot left. Then for this it will be traverse node dot right. I think like that's all. Let's try to run them. Okay, let's do the submit. Yay, it's working. I think like this all. See you next time.